In this video, we're going to be looking at the absolute value function. In the first part, we're going to define absolute value functions as piecewise functions. And in the second part, we're going to use our knowledge of absolute value to solve equations. So, first things first, we're going to take a function like this, the absolute value of 4x minus 12. And actually, we should write this as f of x equals. And we're going to write this as a piecewise function. So the idea of a piecewise function is we want to be able to take that equation, uh, absolute value of 4x minus 12, and define them as linear pieces. So we have a much better idea of when I plug something in, what I actually do with it. So recall that if we do the absolute value of a number, let's say we did the absolute value of 7. The absolute value is defined as the distance a number is from 0. So the absolute value of 7 would just be 7. But similarly, if we took the absolute value of negative 7, that number is also 7 units away from 0. So that would give us 7 as well. So when we're dealing with absolute value functions, we effectively have two pieces, the negative or the positive case and the negative case. And what we're going to do is take this function, f of x equals the absolute value of 4x minus 12, and write it as two separate pieces, one considering the positive case and one considering the negative case. And just as the sake of an argument, we're going to lump in the case of when it equals 0 in with the positive case. It's just going to make things a little bit easier. So what I mean by this is when we write the piecewise function, the first thing I want to do is figure out when am I going to plug these things in? What are the different cases that I've got? So the positive case would be what happens when this quantity, 4x minus 12, is greater than or equal to 0. Again, we're lumping in the 0 with the positives just because we have to put it somewhere. We could put it with the positives or negatives. It's actually not going to make a difference. The other possibility is what happens when this quantity is negative. So 4x minus 12 is less than 0. So let's think about what we actually have to do with absolute value problems in order to solve them. Yes, technically it's the distance from 0, but generally speaking, if I ask you for the absolute value of a number, you're not going to say, well, it's 8 units away from 0. You're going to tell me what the actual number is. So if the number is positive and we want to find the absolute value, we don't really need to do anything except drop the absolute value bars. And so that expression 4x minus 12 that we had in the bars is just 4x minus 12. But when we take the absolute value of a negative number, absolute value is distance, so we have to change the sign of it. So if we had 4x minus 12 and this quantity ends up being negative, well, in order to completely ignore the absolute value part of it and make it a piecewise function, we're going to have to change the sign of that negative component and make it positive, because absolute value is always going to return a positive. So we're going to take the opposite of 4x minus 12, and that'll make it positive. So our next step then is to do a little bit of simplification. So I can't really do a whole lot with that first part. I'm just going to write it as 4x minus 12. The second piece, I can distribute the negative, making it negative 4x plus 12. I also need to take this inequality and this one and actually solve them for x. So I'm going to add 12 to both sides, giving me 4x is greater than or equal to 12. Same thing here, 4x is less than 12, and divide by 4. So x is greater than or equal to 3, and x is less than 3. And so that gives me a piecewise defined function that if I were to take an absolute value of 4x minus 12 or graph this part right here when 4x minus 12 and x is greater than or equal to 3, or negative 4x plus 12 when x is less than 3, the graphs would be exactly the same thing. The functions would be indistinguishable. The challenge is what happens when we have all this other stuff on the outside. So here we've got 3 times the absolute value of x minus 5 minus 2, and we're trying to write that as a piecewise function. The part that can change is the part that's in the absolute value. That's the part that we have to consider when we are setting up our regions. So the regions are going to be when x minus 5 is greater than or equal to 0, so that's the positive case, and x minus 5 is less than 0, that's the negative case, all related to that quantity in the absolute value. So once again, positive case, nothing really happens. I take that absolute value, it's still positive. Effectively, I just drop the parentheses, or sorry, the bars, and it turns into parentheses. The absolute value turns into a parenthesis, or it's the quantity, x minus 5. But when I'm taking the negative case, the quantity in here is going to change signs. So instead of using it as a negative, I want to turn it into a positive. So I need to bring a negative out in front. So this is what my expression will now look like. Notice that 2 didn't change. And that's because that really is just going to move a graph up or down. It doesn't really do a whole lot to the function itself. It just kind of moves it where it's at. And from there, we're going to simplify. Distribute the 3. So we're going to have 3x minus 15 minus 2 is minus 17. Down here, we're going to have negative 3x. This will become plus 15 minus 2, which is plus 13. And then solve those. We're going to have x greater than or equal to 5, and x is less than 5. And so that's how we're going to write a absolute value function as a piecewise function. What we're going to do next is take those same ideas and use it to solve absolute value equations. So again, another option here. We had the absolute value of, let's make it, I don't know, 9 equals 9. The absolute value of negative 9 also equals 9. So what we're trying to do is figure out where does this equation equal 13 for this first one, the absolute value of x plus 5. And the reality is, because the absolute value graph is going to give us something that looks like this, it's going to generally be a V-shaped graph. We're going to have an equation, we want to know where it equals 13, that looks something like this. It returns 2 different places where it equals 13. So how do we find those? Well, I gotta use a little bit of a logic here. So if we know that the absolute value equals 13, I want to think, what number could I plug into this entire expression? What would that expression have to equal to take the absolute value and get 13? There's 2 possibilities. One is that the number equals 13. The other possibility is the expression underneath here equal negative 13. Because when I take the absolute value of a negative number, I get that positive number. X plus 5 could equal negative 13. All right, and then I'm going to solve it. So I'm going to take 5 away from both sides. And take 5 away from both sides. And those are my 2 answers, negative or positive 8 and negative 18. Again, I can take those numbers, I could plug them back in for x and see if they give me 13. And they will. But this one's a little bit more complicated, because if you look at what we've got 3 times the absolute value of x plus 4 minus 2 equals 10. And you might be thinking, oh, I'm going to set this up. And I'm going to set up this equation. And it won't work. The absolute value is the only part that's going to always be positive. It has nothing to do with that other side. The other side, we have to consider what happens when we multiply by 3 and then subtract 2 to get that number. So our better option is actually to isolate the absolute value first, then we can set up our equations. So I'm going to do that by adding 2 to both sides. And then divide by 3. So now that is what I'm trying to solve. And this is a little bit easier logically to think about than the original part that we had. What I'm thinking about is, well, in order to get 4, this part has to equal 4. Or that part has to equal negative 4. And from there I can solve. So take away 4 from both sides. X is 0. Take away 4 here. X is -8. So again, once you've got the absolute value by itself, you can go into a situation where you can set up your two equations, where you've got the positive case and the negative case. Very similar to what we did up at the top, where we're looking at defining the piecewise function.